Hello guys, welcome to DNA Edu. My name is Dhanraj and today we are going to discuss question number 78, which is from Maharashtra Set 2019 question paper. Okay, this is from Set Physics. Okay, let's discuss. The following nuclear reaction is induced by bombarding neutrons on the 13 carbon target. Okay, this is given reaction 13 carbon plus nucleon, it tends to 10 beryllium plus 4 helium. Okay, if R value of this reaction is minus 3.835 millielectron volt, the minimum neutron energy required to induce the reaction is nearly. In this equation we should have to find the minimum neutron energy which is required to induce this reaction. Okay, the question is belong from nuclear reactions. Okay, this question belongs from nuclear physics and the topic name is Q factor, or we can say Q value of nuclear reactions. Okay, before discussing this question we need to discuss some basic of the Q factor. Okay, let's see here what is Q factor and how we can solve the example. Okay, so let's discuss Q value of nuclear reactions. Q value of nuclear reactions. Okay, what is the Q value of nuclear reactions? The energy exchange in any nuclear process or any nuclear reaction is known as Q value. The energy exchange, it means the energy exchange is known as Q value of that nuclear reaction. Okay, let's see here the energy exchange in any nuclear reaction. The energy exchange in any nuclear reaction is known as Q value, of that reaction. Okay, this is the definition. So suppose this is Ma, okay, plus mass of any particle. Okay, and this one is mass of another particle. It tends to, suppose this one is, and suppose this is the any reaction. Okay, this is projectile, this is target. Okay, this is target. We can call it daughter nuclei, and the last one is ejected particle. When any process has been happen, at that time projectile motion or target means bombarding on someone or bombarding on something, and then it get formed that daughter nuclei or ejected particle. This is also known as reactants. Okay, mass of reactants, we also call it mass of reactants, and this one we call it mass of product. Okay, this we can say mass of product. So I can write here EMA and MX are mass of reactants. Okay, this is mass of reactants. Then My and Mb for this example, for this reaction. Okay, only for this reaction we are considering mass of product. Okay, mass of products. Now when mass of reactants is greater than mass of product, at that time the mass defect has been mass of reactant minus mass of product. Okay, this is mass defect, we know the formula. Yeah, we have studied in our nuclear physics subject. Okay, for that we also know the equation of energy. E is equal to mc square. We can put the value of mass, that is mr minus mp. It means E is equal to mass of reactant minus mass of product into c square. this exchange of energy E, we can call it Q also. Okay, this is Q value of this reaction. This energy is called Q value. Okay, now there are two types of there is two condition for Q factor. When Q is greater than 0, that time Q is positive. The reaction is called exothermic reaction. Exothermic reaction, we can call it as exothermic reaction. When the value of Q is positive, at that time we can call it exothermic reaction, and that time energy is released. And that in that reaction we can say in that reaction energy can be released. Okay, and the alternate one is 2. Suppose condition number 2, if Q is less than 0, means it is in negative. If Q is negative, at that time the process is called endothermic process. What? Endothermic process or endothermic reaction, we can call it endothermic reaction. And in that reaction we can say energy is absorbed. And our question in our question there is, you can see R value is minus 3.835. R value is nothing but our Q value in this example. Okay, here the R value is given here, we can say it Q value, that is given in negative. So here we can use endothermic reaction for this example. Okay, just a minute. Okay, now we are going to discuss threshold energy. We have to find minimum energy. What is that threshold energy of endothermic reaction? Here we should know to threshold kinetic energy of endothermic reaction. This is main important for our question. Here we can use directly formula. Okay, what is threshold kinetic energy? The minimum kinetic energy of projectile to start endothermic reaction is known as threshold kinetic energy or threshold energy. That is minimum energy. We can easily say that minimum energy. The minimum kinetic energy of projectile to start endothermic reaction, is known as threshold kinetic energy of endothermic reaction. Okay, this is our definition. Suppose this is mx, this is our projectile. This is just for example, to understand we are giving this example. Suppose this is our target, and then the product of this reaction is something like that. Okay, this is our process. In this we can we use the formula is, suppose KTH, kinetic energy, threshold kinetic energy. I'm giving here threshold kinetic energy is formula for threshold kinetic energy or minimum. There is directly formula to find minimum energy. Okay, that is threshold kinetic energy. Formula for this is minus Q into 1 plus mass of projectile upon mass of targeted. Okay, you can see here this is our formula. We should have to use this formula directly in this equation. At that time we can solve our question. Okay, suppose this is for only 2 items or 2 products. Okay, if there are many items, many if there are lots of masses or lots of particles, then we can say, if at that time we will use this formula. Okay, this is direct formula. Let's suppose there are 3 4 plus 5, there are lots of particles in the reaction. At that time we will use this formula. Just remember for your information, less chances are there the question has been asked on this number of reactions, okay, number of particles reaction. Then if there are number of particles in the reaction, at that time we will use this formula, that is threshold kinetic energy is equal to minus q, then mass of first atom or mass of first plus mass of second plus mass of third plus mass of fourth up to dot 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 the number of all, and 2 mass of m2, mass of second particle. This is our threshold energy for number of atoms or number of molecules, number of masses. Okay, this is our just general information. Now we are going to use this formula. Okay, just remember, we can see here the formula is our kth is equal to minus q into 1 plus mass of proton upon mass of targeted atom. This is our formula to find minimum energy. Okay, so we are going to discuss our reaction. Our reaction has been given 13C plus nucleon, it tends to 10 beryllium plus 4 helium. This is our reaction. And see the question, in this question they said the following nuclear reaction is induced by bombarding neutrons on the target carbon. There is directly given the neutrons are projectile which is bombarding on the target C. It means the target is our target is carbon and our projectile is neutrons. Okay, so let's see here. And here, if the R value, our R value is nothing but our Q value. Okay, just remember for this question, here our R value is nothing but our Q value. So we are going to find here. Okay, that is Q value is given, that means our Q value is given because R is given here, that is minus 3.835 is our Q value. That's AMU. This is our Q value. Okay, so now we are going to use here our directly formula. We have to find minimum neutron energy required to induce this reaction. Okay, induce this reaction. So let's see here, E minimum is equal to, or ETH we can solve, ETH or KTH we can say is equal to minus Q into 1 plus mass of projectile upon mass of targeted. So in this we can we know the values of mass of projectile, that is neutron, is 1.008665 AMU. Okay, we know the mass of nucleon is 1.008665 AMU, and also we know the mass of carbon or mass of target is 12.01. This is just basic knowledge, I think you already know. I am not going in deep, I am just putting here directly values and we can solve. Here mass of projectile is nothing but our nucleon's mass, and mass of target means our mass of carbon. So we can put here the Q value has been already given. Suppose this is our minus Q, minus as it is Q value minus 3.835 into 1 plus mass of projectile is 1.008665, and then mass of targeted item is 12.01. This is our formula, just we have to solve it. This one minus get plus, that is 3.835, and if we are going to solve it, that is 1.0840. I use here calculator, you can use directly calculator, and the final value is 4.115 milli electron volt. This is our final value. Okay, this is our minimum neutron energy which is required to induce this reaction. To proceed this reaction, we need this minimum energy. Okay, this is our answer. In this question you can see 4.13 is milli electron volt, is answer is near about 4.15, so I think this one is correct answer. Let's discuss once again. In this example, the following nuclear reaction induced by bombarding neutrons on target C. We are bombarding neutrons on the target, on our target, that is carbon. Here we are bombarding neutrons on carbon, and after that the R value is nothing but our Q value, okay, that is given here, and they ask us to find the minimum neutron energy required to induce the induce the reaction is nearly. So we should have to find the minimum neutron energy required to induce this reaction. We find that that is 4.15 millielectron volt, and our answer is near about 4.13 millielectron volt. The answer is B. Hope I think you understand this example. If you have any query, you can directly ask to me. Okay, for more videos, please stay tuned and please share to needful person. Thank you so much for watching the video. Thank you.